Welcome back, guys. We're moving on to our next topic of maths here. We're going to conquer formal division. What is formal division, you might be asking? It's when you set up an equation like this one here in the diagram using this method here, which would be called short division, which is what we're going to focus on today as well, where we divide any number by a single digit number, like the 5 over there. Some of you might be rolling your eyes right now and sighing because we're covering division. It's a big, scary topic. It's not something that everyone understands straight away, but that's alright. That's what this whole video is about. It's to make you feel a bit more confident and secure in your understanding of how to divide bigger numbers by single digit numbers. Okay, and I'm going to show you how. Using some of this vocabulary here. We've done multiples and factors before. Easy peasy, we know what they mean. We know that factors can be multiplied by each other to create multiples, and they are going to link to what we're doing in short division. Again, that's where you divide any number by a single digit number, and then you have the dividend and the divisor. And after hearing that, you might be thinking, what? That's probably completely understandable. You might think, what on earth are those things? I'm going to show you rather than just tell you. So when you set up a formal division equation like this one on the left, you have two main parts to it. You have the dividend, okay, that's the number that is being split into a number of different parts, equal parts, and you have the divisor, okay, that is the number of parts that you are splitting the dividend into. All right? And it makes sense really in the name, doesn't it? The divisor, it sounds like a villain or a superhero almost, but it's what the bigger number is being divided by. It's what it's being split into. Okay, and just a recap on factors and multiples here on the right. Two or more factors, when multiplied against each other, can create the multiple, the answer. All right. So let's crack on. Let's actually do this one. Let's actually divide 396 by 3. Let's split 396 into 3 equal parts. Because we're splitting it into 3 equal parts, we're dividing it by 3, it's good to know your 3 times tables. That's why I've got the multiplication table of 3's out here on the right, because that way I don't need to count on my fingers every single time up in 3's if I'm not so confident with my 3 times tables. I suggest you do the same in the future if the divisor is a different number, okay? And if you write it on a piece of paper once, then you don't have to do it again and again every time. You just keep that piece of paper and refer back to it whenever you need to. Okay, so first step should be should begin with a question, really, and that question is how many sets of 3 are there in 3? We ask ourselves, we're going to do this digit by digit, and that means we have to start here on the left digit of the dividend, and we think, how many times can I fit 3 into 3? Well, just remember that you can only fit one set of 3 into 3, so our answer is going to go up here on the top. Our first digit is going to be 1, because only one set of 3 fits into 3. Make sense so far? Excellent. Next we ask ourselves, how many sets of 3 are there in 9? Because that's the next digit along. And then we refer back to our multiplication table. We see that 3 sets of 3 make 9. So what do you think is going to go up here above the 9? It's going to be 3. Cool. Okay, and now we're on the last digit here. We ask ourselves again, how many sets of 3 are in 6 this time? Refer back to your multiplication table. How many 3's make 6? You can see that 2 sets of 3 make 6. So the final digit in our answer is 2, giving us a final answer of 132. When you split 396 into 3 equal parts, each part is worth 132. Cool. Okay, so that's if all the digits fit in quite nicely with the 3 times tables. But what if they don't fit in so nicely? What if you end up with digits that can't be so easily divided by the divisor? What if you've got something like 847 being divided by 5? Well, again, just take it on with the same steps as you did before, but obviously this time our dividend and divisor are different. With our divisor, we need to recognize that that is a 5, and therefore we're going to need to know our 5 times tables. So that's why I've copied out the multiplication table for the of 5s out here on the right, so that I know how many groups of 5 are worth what. Again, let's start with the first digit from our dividend. We have how many sets of 5 are there in 8? Well, we should realize that we can't go above 8, because then that's going to be too many sets of 5 and they won't have enough space to fit into. So we're going to have to go for the lower option rather than the higher option, which means that we can only fit one set of 5 into 8. That's the closest we can get without going above 8. Alright, so if we were to go to 10, that'd be too high, it wouldn't fit. So what do? We put 1 above the 8, but we need to recognize that we had 8 to start with. The closest we could get to was 5. We've used up those 5, that set of 5. That's why the 1 is there. But we've got to realize that there is still a remainder. There's 8, and then you use that initial 5. You take 5 away, and you're left with 3. That 3 still has to go somewhere. Okay, and hopefully you might remember that it's got to go into the next place value column. We just shift it along. We actually use every single digit and every leftover. We just move it along a column. Okay, so because it's going there, that changes the value of this 4 to 34. Now we don't add them together. We're just connecting them in a way. So the value of that digit changes completely now. And we ask ourselves next, how many sets of 5 are there in 34? Okay, 34. Remember that's what that represents now, and it's important that you actually write this little digit above in this column whenever you're doing this by hand. Okay, so how many sets of 5 can we fit into 34? What's the closest we can get without going above 34? Well, we check our multiplication table and we see that 6 times 5 will give us 30. That's the highest we can get to 34 without going above it. So 6 sets of 5 make 30, allowing us to put 6 above here. However, we still got to remember that we had 34. We could only use 30. We take that away from 34, we're left with 4. That 4 has got to go somewhere, guys. So, of course, we just move it into the next column, changing the value of that digit into 47. And we're on the last step again here. We ask ourselves, though, how many sets of 5 are there in 47? We check our multiplication table. We see that the closest we could probably get is 9 sets of 5, which is 45. So, of course, what do we put above that? We put 9. Okay, and again, we always need to remember, have I used the total value of that digit? No, I haven't yet. I had 47. I used 45. Okay, I took that away, which leaves me with a remainder of 2. Now, there's no other column to put that 2 in this time. So what do we do with it? We just leave it as a remainder. Okay, we need to include that small r and the value of the digit next to it, and your final answer would be 169 remainder 2. When you divide 847 by 5, you get 169 remainder 2. It's very important that we make sure that remainder 2 is included in the answer there, guys. Okay, so it's now your turn. Okay, try these out. Freeze the video here and give these ones a go. You've got the mild section where there won't be any remainders, and then the spicy section where the answers will include some remainders. So have a go at these at home. Send me your answers and I'll go over them. And also, if you get stuck on any, if you just feel like you can't do it, let me know which one it is and I'll help you through it. But thank you so much for sending in all your hard work, guys. I'm really impressed with the competition that you guys have kind of set up amongst yourselves, and loving the work that you guys are getting up to. So keep it up. Okay, you're doing really well. Alright, thank you. Bye.